Good morning and welcome to this Man and Machine webinar in which we are going to be discussing BIM and the use of Revit as a BIM tool, a BIM design tool, and its application to the BIM process. My name is Phil Reed, I'm the Managing Director of Man and Machine, and I'd like to thank you first for taking the time. I'm joined today by two individuals. Firstly, David Wilkinson is one of our senior consultants, and David will be running most of the content during the webinar, and also Steve Massataro, one of our other engineers, who's here to help answer any technical questions you may have at the end of the session. So the session basically is divided into two sections. Firstly, I'm going to talk a little bit about BIM and the ideas and the concepts behind BIM, and try and demystify some of the content, some of the information you may see bandied around the internet and other publications. And it's really just a quick introduction to BIM. Obviously we can offer more help, but the main content, as I say, will be delivered by David, who will be taking you through Revit and its application to the BIM environment. So firstly, let me start by saying, clearly it takes many different activities and skills to bring the ideas and designs of architects and engineers to fruition. And I think building information is really just as an extension of that, and what it really does is it attempts to standardize the creation of and exchange of information, really to make the design, construction and operational management of a facility or infrastructure or an asset more efficient. And I think that's really important, because the operational management side of BIM is really where a lot of the benefit will be derived in the future. But it's probably the most underdeveloped side, although we are going to focus today mainly on the design side of using a tool like Revit to implement a BIM compliant environment. So really BIM for me really just reminds us that we should constantly evaluate and re-evaluate the way that we manage information, and it's really about managing that information to improve the collaboration and drive cost efficiencies and productivity during a project. So what this slide really talks about is really try and introduce some of the concepts. I mean, BIM itself has its roots back in as far as 2002. Some people would argue its infancy, or it was born really in the United States, and people would argue by NASA and the White House, who really introduced the concept, but it very quickly became the auspices of the US Government Services Agency, who are the group that are responsible for the design and management of all federal buildings in the US. That said, I think personally that BIM is not really anything new. I think the concept of BIM and management of information in architectural and construction products candidly has been around for a very long time, and you can even go back to 1962 when a gentleman called Douglas Engelbert, who's an educationalist, in his paper on augmenting human intellect, suggested the use of object-based design, parametric manipulation and a relational database, and that they would be key components in the future of the designer's toolkit, which to me sounds very much like BIM. And what you see here is some of the aspects of BIM that maybe you've considered, and certainly you should be considering, because BIM is not just about the graphical model. BIM itself, of course, is increasingly popular in the UK. It touches construction, facilities management, civil infrastructure, and even now many of our customers are product manufacturers and fabricators, and clearly it's touching them as well. The extent to which BIM information is required is not actually, as I say, just limited to the CAD model. In its true sense of the word, and the true sense of what the government is trying to impose or ask for with regard to BIM, it's also about many other documents, policies, assumptions, strategic decisions, manufacturing data, user assessment, regulatory data, client specification, maintenance instructions, and so on. All of these different elements of a project, or documents generated during a project, definitely form part of the model and part of the BIM model. I think also BIM as a three-letter acronym is a bit misleading, because it's not just about buildings, and I would argue in fact that it's more about the information and arguably also more about the management than it is about building, and it actually is being applied not just to buildings but many different types of assets or facilities or infrastructure. It's used in civil engineering. An example might be you can use BIM for the design and construction of a bridge. It doesn't have to be a building. And that's very important. So, for me, BIM can mean many different things, and many different people have used different versions of the acronym. So it could equally mean better information management. It could mean business improvement methodology. It could mean building industry modernisation. And to my mind, all of these things are relevant when you start to think about what BIM is designed to do, which is really to generate a more collaborative environment. And yes, it includes 3D modelling, or a modelling tool which uses intelligent objects and parametrics. But if you think about the activity of the life cycle of a building or an asset, then it's about the design, it's about the construction, it's about the program management or the project management of a project, it's about using it, it's about maintaining it once you hand the project over to the owner operator. It's also about management, and by management I mean the planning, the organising, the resourcing and controlling of a project. And as we've already said, it's also affecting the building fabrication industry, the civil engineering industry and the supply chain generally. So it's fairly wide reaching, and if you start to think about what is the adoption like of BIM in the UK, well, the NBS recently published their National BIM Report 2014, so it's quite recent, in which they surveyed over 1,000 UK construction professionals, and it reveals that BIM has increased adoption from around 13% in 2011 to around 54% in 2014. So it's widely adopted now, and increasingly so. And in that paper by the NBS, they go on to explore the clear benefits of visualization, collaboration, information retrieval, construction simulation and sequencing, and so on and so forth. They also go on, interestingly, to explain how for manufacturers, providing accurate product information in BIM models or in BIM format has the potential to not only determine the product choice during construction, but also the ability to provide consistent information and future business opportunity in the ongoing life of a building. So BIM really is being before I go on, Project Lifecycle Information Management. That is just an acronym that I dreamed up. I've heard it before in a different guise, but you could use PLIM if you like, and it's probably a more accurate representation of what BIM is all about than the three-letter acronym itself. So what are the components of BIM? If you're going to implement a BIM strategy, firstly, think about BIM as being applied to a project. It's quite realistic to think that you might be a single company working for 2 or 3 different main contractors, for example, and you could have 3 separate implementations of BIM using different tools and different methodologies, because that's what the main contractor is asking for. So they would all be BIM compliant. Obviously it's to a company's benefit if they can implement consistency in their BIM strategy, but that's the reality of the situation you could find yourself in if you are working for a main contractor, which is where a lot of the drive is actually coming for BIM related projects, primarily because it's the main contractors that work for the big government agencies, and they are mandating BIM, as you all know, and that the projects need to be BIM compliant by 2016. Of course, that's likely to permeate itself throughout the entire main contractor organisation and find its way onto civil projects as well. So what are the main components? Well, without boring you with too much detail, there are a number of different elements you need to be thinking about, and the first one obviously is pretty mandatory. If you look at the government construction strategy and the kind of things that they say in there, it's fairly simple. You can boil it down to 3 things. The first one is that you have to implement 3D modelling. The second one is that you have to exchange all information on the project electronically. And secondly, that you have to have a CDE, or a common data environment, which basically means you need to settle on the project on some sort of information exchange in terms of the not firstly the standard you're going to use, but also the common data environment. And that's where some of these elements come in. So it's given that you have to do 3D modelling, you also have to manage your data. That's not new. Architects have been doing that for a very long time, and main contractors have been doing that for a very long time. But in the true sense of what the government wants BIM to do. They want you to electronically collaborate and have, if you like, working folders or working spaces where you will exchange data and store data electronically for people to access. And obviously when you do that, it's very important in our experience to make sure that the security of the setup is such that the right people are accessing the right information and only the right information, because you could have multiple different types of company obviously working on a project. So data management and cloud services are interlinked. You can of course have your own data management system as a private company, but cloud services and portals are becoming increasingly important for the sharing of that data with other trades and other contractors. So the typical type product you'll see there or solutions you'll see are things like A-Site is a very common one for a lot of government projects, and also things like Buzzsaw. Object libraries are a necessity. Many of our clients now, and particularly the fabricators actually, are asking us to help them implement project libraries, or object libraries, sorry, whereby we are helping them build BIM compliant models for whatever product it is that they're selling, that they can be put into places like the National BIM Library, but also used by their customers, whether they are architects or prime contractors or whatever, to actually pull the models into the overall modelling package, and that those models get brought in with all the BIM attributes applied to it. I think the final thing to say is BIM is not just about the technology, it's much more about the process and the workflow and making that efficient and collaborative. And team members are very important, and I've seen increasingly now that on many larger projects there is a new function which is a BIM manager who's actually appointed to a project to make sure that the BIM strategy for that project is adopted correctly, and that the quality of the BIM information being provided is accurate and as expected. And finally, as I said earlier, the government construction strategy does define that you have a certain data exchange standard. They talk very much about the COBE standard, but there are other standards around as well. But COBE and IFC are the common standards that you'll find in the UK that people are adopting in terms of implementing BIM as a solution. So that's really just an introduction to BIM. I hope that you found that useful. Obviously there's a lot more content behind this, and of course we'd be happy to help you with that. I just want to say a couple of words about man and machine services and products, again without giving you a sales pitch. But what's really important is, you know, a lot of people are at different phases of their journey with BIM. Some at the very early stages, haven't even started, and some are a long way through it and have BIM directors and BIM managers already appointed in their organisation. I'll repeat what I said a few minutes ago, that BIM is about the project. So you could have different BIM implementations, strategies, technologies or standards on different projects, depending who the main contractor or customer is. But of course it would make sense if you could normalise or rationalise that in a way that as an organisation you could cross-fertilise the technologies that or standards that they use into many other projects, because that would give you a lot more flexibility within your organisation around your resourcing. And we'll often be brought into a company to help them implement their BIM program. And these are just some of the aspects of the BIM program. I'm not going to go through them all because we don't have time, but just have a look at some of the key points around why organisational vision, why are you implementing BIM, what is the modelling plan, what is the staffing plan, what kind of skills do we need, what sort of training do we need, what is the systems and process plan, how are we going to collaborate and manage our data, and how are we going to share that data with third parties. And finally, the software technology plan. And there are many different areas that you'd need to look at in terms of the solutions that you will need to get into the more mature areas of BIM, in terms of things like 4D and 5D, which are things like construction planning and cost system integration, if you like. So very happy to talk about those things. I'd also like to leave you very quickly with a quick look at some of the products in our BIM Solutions portfolio. So you've got the obvious ones. I will say something about Revit before I hand over to Dave, because Revit is, to my mind, in most customer situations we go into, it tends to be the dominant software platform for BIM in the UK today, and that's just a statement of fact. And that product can also be found in the Building Design Suite, which starts to add in some of those other functions like Navisworks, which bring in simulation and construction sequencing. But I've put Inventor on here as well because a lot of our product fabricators and manufacturers will actually need to build Inventor models for manufacturing and then export those models in a BIM compliant way into Revit for the architectural and design side of a project. So that's another product that we use. Buzzsaw is one of the management products. So they're the Autodesk products. A couple of other products I'll just quickly mention. One is G-Info. I said at the very beginning that facilities management was one area that was not heavily developed yet in terms of BIM compliancy, but G-Info is one of those products. So it's a bidirectional system that will take all of the information from the 3D model or even from AutoCAD and integrate it into the back end, into the processes, into the databases like Oracle and SAP, and so you've basically got a facilities management product that will derive a lot of the data it needs for the ongoing management from the BIM models. And the final product I'll just quickly mention is FlexiJet. This is a laser scanning system mainly used for interior designers, kitchen planners, those kind of people who need to create a parametric drawing, if you like, of a building when there is no drawing available. So many projects, about 80% of projects, are actually refurbs. And using a product like this, which is very simple, you can take some laser point scans of a room, for example, and you can reconstruct that room directly in Revit. So as you make the measurements, it actually draws the room in Revit without any manual intervention. So it's a very, very neat and very simple mobile BIM measuring system. So they're just some of the products that we have in the portfolio, but clearly the product we're going to talk about today is Revit, and that is the responsibility of David, and I'm going to hand over to David now to take you through the Revit platform with respect to BIM implementations and BIM designs. So David, over to you.
Okay, so today we're going to do a brief overview and a demonstration of BIM, or well, more specifically Revit, and how Revit creates BIM data and allows you to produce that BIM model. The agenda for today is going to be a brief introduction of Revit as the product, just a quick talk about the interface, how it actually looks and works. Then we're going to look at some building creation from something called mass modelling, so it's like a concept model. And just briefly touch on some of the detail that we can get out from creating that mass model. Then we're going to look at building creation again, but really from scratch with Revit. Just going through functionality and give you a feel for what Revit's about, but also obviously relate that to what BIM's about, and from how we integrate that BIM data, or how that BIM data is already within the model as we create it. And then last but not least, we're going to just cover a brief manufacturing workflow where we're taking mechanical manufacturing data and how we can simplify that and then bring it over into the Revit environment, complete with BIM data or not. It's entirely up to yourselves. Okay, so that's the agenda for the demonstration. Okay, so we're going to start with a brief demonstration of a concept model or a massing model within Revit. Just produce a building outline, and then from that we're going to just get some details, some schedule details, which will start populating some BIM information and giving us some BIM information, and also showing the benefit of using Revit to design buildings. So what I'm going to start with first of all is an AutoCAD underlay. So I'm just simply going to import an AutoCAD drawing, standard AutoCAD drawing, nothing fancy. Comes in our plan view, because that's where we are in our particular level, which I'll come back to in a moment. And from this plan you can see we've got an existing building on a site and a proposed building. So this is the area that we're interested in. Okay. So if I come into our massing tools, and what I'm simply going to do is trace around the outline of this building. So the first thing to note here is that the tools that I've got for any type of creation, or pretty much any type of creation in Revit, are identical to AutoCAD, and they work in the same way. So I'm going to just start snapping to these corners in sections, just like you do in AutoCAD, nothing different here. And of course you could start completely from scratch. You don't need to start with an AutoCAD drawing. You could draw this completely from scratch if required. But this is just showing you how you can reutilise some of the existing data you have, or maybe integrating with somebody who's still using 2D AutoCAD. Now that I've drawn around that, you can see I've got this boundary or this outline. If I select the outline, what I want to produce is a solid form. So if I tell it to create that, we don't see much in a 2D orthographic view, but if I go to a 3D view, you can see what we've got now. So we've got this 3D solid based on the boundary that I sketched or drew. I can easily change the size of this, or I can be specific with dimensions. Let's go in for 12 meters. Okay, and that's now produced a basic lump for me, or a basic solid, or a mass as we call it. I'll just shade that in so you can see it a little easy. So what can we do with that? What's the benefit of doing that, other than we've got a 3D solid, which is, I mean, yeah, quite basic really. Well, first of all, if I highlight the mass and look at our properties area, as I said before, this is quite relevant for anything that we do in Revit really, because it's giving us information and statistics about what I've actually selected on. So in this case we can see surface area and volume. That information is automatically given to us. We can resize this, all that information automatically updates. Okay, so that's the first thing, sort of standard 3D modelling functionality if you like. But we can go a step further with that. We can say, well, you know, I've got this mass, that's the outline of the building that I want, but what about putting floor levels in now and starting to you know, be more specific about the building? If we look in our floor plans area in the project browser, I have level 0, and I have level 1 at the moment. So effectively ground floor and first floor. If I go into an elevation, we can see our basic mass there, and we can see our levels defined. And what we can do is we can add more levels in quite easily. So if I come in here and say, let's just select another level there and another level here. So we've now got 2 levels, 4 levels rather. We can rename these. So if I choose to call this ground, it's now renamed in the graphics view, but it's also renamed in our project browser. And this is one of the real key things to understand about Revit, is everything's dynamic. It's an intelligent model, as opposed to 2D system where you're basically drawing lines, arcs and circles. This is generating real data, and that's where the BIM side of things really comes to play in. Okay, we can adjust these at any point in time. I'm doing them now just after I've created them, but it could be as you go through the project if there's a design change. Or we can say 3000 for 3 meters, or we can just say 3M and it'll shift those levels around accordingly. Okay. If I go back to a 3D view now, that's great, but as far as this mass model goes, there's, you know, it's not changed anything. So what I'm going to do in there is apply those floor levels to our mass model. I can apply one floor, all floors, or, you know, selected floors. And it just puts the floor levels through the mass. So we can actually see them now, which is great graphically, but we also need to understand what the real data is. So I can go into each one of those levels and I can look at its properties, which is great. I'm starting to get more detail now based on this floor level. But we can go a step further than that, and we can produce a schedule. We can schedule many things in Revit, but this is just one. So if I come into here and say I'm interested in the floors, and I'm interested in floor area, floor perimeter, and we want level as well. So those are the 3 things I'm interested in. If we sort by the level, we want to include grand totals. Okay. And then if we go to floor area and calculate our totals of floor area, and floor perimeter, and calculate the totals there. Basically that'll give us exactly what I've asked it for. It'll roll up the totals, give us an overall total of floor area, which obviously can be useful, and floor perimeter as well. Again, the benefit here is that this is all dynamic. So if I come back to our mass model and choose to pull this around a bit, just increase it in some way, change the design. Again, it's a concept model at this stage. If I now go back to our schedules, you can see that those values are updating automatically. And that's the real benefit of producing a BIM model, if you like, in Revit. Everything's dynamic, everything's linked together, so as you make changes, all the other information is updating automatically. So this isn't a fully fledged, this isn't all the BIM data that you need, but it's part of the BIM data that can be relevant. Okay, and that's just a brief introduction and flavour of concept or mass modelling within Revit. Okay, so we're going to move on now and look at creating a BIM model from scratch, or a Revit model from scratch, and just show you where BIM's being derived from, such like. So I'm going to start a new file from here, but just to highlight, there's a portion of the interface here with Revit called families. Revit families are where our BIM models come from, if you like, and a family is basically a file with the right information inside of it. You'll see this more clearly as I start designing the building, but families is where manufacturers are creating a Revit family model with information in. That information is the information about what the model itself, what they manufacture, and also the BIM information that's relevant to that model. So I'm going to start a brand new document here, and we've got nothing in there. I'm simply going to start, it's only going to be a very basic building, but I'll simply start creating that building. So if I decide to add walls in first, it's a good starting point. I can choose what type of wall it is that I want to start with, so I'm just going to go for this default cavity basic wall. But as soon as I do that, you can see in here that we've got properties about the wall. I've not even drawn anything yet either, but this is about the family for that wall. I can go in and edit that family, so I've got a presentation of how it looks graphically, and then I've got some information about the wall itself, including some analytical properties. And if we go in and edit the wall, we can see how it's actually made up. So this is the sort of BIM information we're talking about, or one part of it, where the model I'm choosing to use to create walls in my Revit building has all the information embedded inside of it. And that really comes back to the BIM standard and the whole idea behind having a full digital model with all the information embedded in all the components within the building. So how that works is, if I let's just draw something quite basic for now, kind of this sort of a room shape. Zoom in a bit. Okay, so there's our wall. I mean, the first thing to notice is the detailing on the wall, the cavity, all that information's gone in automatically. It is a 3D model as well. At the moment we're just choosing to work in an orthographic view at level 0. So from the mass modelling demonstration that I've just done, we added more levels in. We'll do the same in here in a moment, but for now we just have 2 levels. Just to prove that it is a 3D model, there is the wall. The wall comes in as a default height just because I've chosen to draw it that way. So at the moment, if I highlight the wall and select it, you can see from our properties window the type of wall we're using, where it actually starts, so on level 0 typically, but at the top it's unconnected, so it's just given a default height of 8 meters. We'll come back and change that in a bit, but for now that's as much as I'm going to do. I'm now going to add another wall. This time I'm going to choose a different family, so different BIM information. We'll go for a partition wall, and we'll just create some basic partitions in our room. Nothing too fancy, pretty straightforward really. It should do us. Again, one of the benefits you see straight away is it's just sorting out all the detail in the joints in the walls as we go. So again, relate that to traditional 2D AutoCAD. You're having to do a lot of trimming and pulling things back, and doing all the usual stuff that you do in AutoCAD. Revit, even in this view where we're working orthographically in 2D, we're using familiar AutoCAD commands, so lines, arcs, circles, but when we drop that down, because it's using this family information, all the information is embedded into the file, so it knows what it should look like, it knows it's a certain thickness, and then we've got all the metadata that's in the background that's relevant for the BIM model itself and for the BIM standard. Okay, just stick another partition in here just because we can, something like so. So there's our partition walls done. If I just highlight a partition wall, you can see again it's starting at level 0, but it goes up to level 1. We could change that if we had more levels, but in this case it just goes to level 1. So we haven't got an unconnected height, it's actually given a height based on our levels in our project. Again, I'll come back to that in a moment. So if you want to add some doors in, we've got a standard external double flush door, but if I go for some internal doors to start with, and say I'm just going to place that door down there, that door down there, and maybe a door here. Okay. Different sizes of doors. So these doors here are one single family. This is a single family of door, but we have different sizes embedded in there. This door here is the wrong way round, so we can just simply come in and flip it. And again, we've got dimensions on here, so if we wanted to specify a size, we can just move things around. It's very, very easy to use. It is literally like dragging and dropping components from a library onto your model, and it sorts everything else out for you, connection detail and all that good stuff. So we've got some internal doors, we want some external doors as well. This time though, I've only got basic doors loaded with my project. So what I can do is I can come and go into the doors section of the standard doors that come with Revit, and if I look at external doors, these are all the families of doors that I've got. So these are a type of door with different sizes typically. Okay, so this is what would come from a typical manufacturer of doors. These are the ones that ship with Revit. So what I'm going to do is find a door, what door to use. I want a garage door. Let's just go back up a bit, find something a bit better. In fact, let's use one of those as an entry door. So what it does is it loads that family into the project that I'm using, and now I've got it available in my drop down list here. There's only one size for this particular type or family of door. So again, all I've got to do is decide where to position it. Simple as that. So if I drop it down there, that's my door in. Again, all the details in, everything's set up correctly. Now if I want to, if I don't want to use the standard stuff that comes with Revit, which generally you don't, well, I say you don't, it depends what you're trying to achieve. If you're working with certain manufacturers, then you want the manufacturer's data. And if the manufacturers created their BIM model for their piece of kit correctly, then all the information should be in there. So just to give you an idea, let's just go back to the start page. This is Autodesk Seek, which is one location for BIM files. Okay, and you see here different types. Or we can just do a straightforward search. So if I just do a search on doors, then you can see here I can look at manufacturers, types of doors, yeah, what there is, whether it's a Revit architecture file, Revit MEP file. So I can be really specific on what I want to look for. In this case, I'm just going to go to a sliding door and have a look in the list. And these are the sliding doors that are available on Autodesk Seek. There are other libraries out there, lots of other libraries, BIM Exchange and such like, that are not Revit centered if you like, but you can still download those files and use them in exactly the same way. So what I've actually got, what I should have, is if I go to, let's go to Windows actually. So we'll do a sliding door rather than a more traditional door. So I'm going to load a family, but this time I'll use one of the downloaded models from Seek. I haven't downloaded it live, but that's in there. So, right, okay. It is actually a door, not a window. So when you're loading families in, because of the way families they connect into the existing model, so they need to be of the right type. So if I bring that in as a door, that should work. Yeah, there you go. So that's now loaded into the project. It's a 4-panel door, and then it's just the same as before. I just come in and choose where to put it. So if I want maybe a sliding door there and a sliding door there, I can just drop those in, and you can see straight away that, again, all the details there. Now that's been done by a specific manufacturer out on the web. I've downloaded that and I'm using that inside of my BIM model. Okay. Again, if we come in here, I'm not entirely sure what properties are available. And you can see the preview, and then you can look at, SAS finish. You've got relevant detail that relates to what this manufactured item or component is that goes into the building. Okay. So that's been done by the manufacturer, not by Autodesk, or not out of the standard libraries that come with Revit. Okay, so yeah, that's about it really. That's as much as I want to cover there. So if I come into a 3D model now, straight away, you can see all that detail's come in. Got all that detail, including if we're looking through the window, we can see the internal doors. Okay. If we go back to our level 0, we need to put a floor in there. So you'll notice really we're just working, not quite left to right, but we're working along this portion of the toolbar. We're simply going to come in and say I want a floor that connects to our walls, and it's this type of floor. So again, hopefully you can see that this area here, the properties area of the of Revit, is very important. It's where we specify what we want to drop in. But we're not doing like we do in AutoCAD, where we're actually drafting lines, arcs and circles. There's my flooring. If I come up to level 1 now, I can drop a floor into level 1 as well. So I'll choose a different type of floor this time, so timber suspended floor. I'll just connect that through. So if I briefly go back and look at my 3D model now, you can see we've got the floor slab on the bottom, and we've also got the floor in there for the first level, or the first floor. Okay. If we come back here and just do a quick sectional view, so if I choose to draw a section line through there and then go to that section view, this is what we're actually getting. Okay. There's no manufacturing detail, not manufacturing, but construction detail on there yet. I'll come back to that in a minute, but that's as easy as it is to create a section view. Draw your section line in and then just go to the section view itself. I'm going to look at elevations, and I'm going to choose to put another level in there just to add some more detail. Just the same as you saw with the mass modelling demonstration. I'll just drop that in and line it up with what we've already got. Actually, well, 3.1 meters is fine. I'll leave it at that. At the moment, though, the building's actually too high. It's going past that top level. We're only going to produce a couple of levels in here, so that's not quite right. So what I can do, and I can do this from any of the views. Don't have to be in an orthographic view. I can do it from a 3D view, as you see here. I'm simply going to go in and say that the wall is connected to the top of level 2, or the top of the wall is connected to level 2, and that's now changed the height. I just go back to my north view, you can see that that's aligned. The good thing though is, again, everything's dynamic, so if I choose to move this up, the wall follows it. So the wall is physically attached to this level, so it's the level that's driving things. Okay, so there's our basic plan view. We want to start putting furniture inside there now. So at level 0, I'm going to choose to add, again, these are the standard families, so I'll just add a few desks maybe in here. Again, this isn't the best building layout that you'll ever have seen, but it's not really about designing buildings, it's about showing you functionality, I guess. Yeah, that'll do. So we could have, move our desk round, place them wherever we like them. We've not put any well, we have put windows in, but not really in the offices. So let's just quickly put, again, load a different family in. I'll just use one of the default ones from Revit. What should we go for? As you can see, there's quite a few, so I'll go for one of these, a rectangular bay window. So if I'm going to add that in, literally I can choose different sizes. You can see there's quite a few different sizes here, so we'll go for a larger one. And we'll say we want a bay window here, maybe a bay window, hit that a little bit. Okay. So again, all the details placed in for us automatically. That's at level 1. If I now come up to level 0 rather, if I come up to level 1, I can do the same. I could put some partition walls in. So yeah, same type of partition wall, but this time we'll just partition right across. Just do some very simple detail. Again, we could drop doors in, so on and so forth, but it's just more of the same stuff. The point here is that I'm working at a new level. If I add a window in, now because I've already loaded that additional family of windows in, they're available for me to use again. So I can simply come in, in fact let's choose the largest size for the upstairs, and I'm going to choose to put one there, and we'll drop one in there. Again, just to show functionality rather than trying to design a proper building. It's a bit of a mishmash, to be honest, this one. If we go to the 3D view now, you can see straight away that all that detail's gone in. Okay. But the real beauty is that every time I put one of these family files in, whatever it be, is that BIM information lives inside the file, and that's what we're doing. We're building this BIM model up as we go. Okay. So I'm just going to jump into level 2. We'll just quickly finish the building off very basically. So I'm just going to go for a basic pitched roof. And we'll click on there. We'll just accept the defaults on pitch and such like. So if we now go to an isometric view, should have put a ceiling in there, but the ceiling's just the same as the floors. We're just adding it in and then telling it what height and connecting height. Okay. So there's our roof. If we wanted to, I suppose we could come in and drop a gutter on there as well. And again, you know, these are the standard default families that come with Revit, but they could equally be a manufacturer's detail that we're adding in and building that BIM model up. There we go. If we look in the corner there, now we've got a gutter laid on there. Just one thing I didn't really highlight, if I select my window, or this window, and again I can do that in the 3D view or wherever I like. If I look at that, you can see I've got the sill height specified on there, so if I don't want a standard sill height I can change that. So if I want it at 1000, tell it to apply it, it'll drop down. So again, everything's dynamic, it's all parametric, we can go back and change things very, very easily. Okay, just go to an isometric view of that. So from a construction point of view, there's obviously a lot more we could do, and we've got different levels, so we typically put a set of stairs in, things like that, so you could get to it. But it's all the same sort of theme. We're using families within Revit to go and get information, objects to put in. So it's a bit like using blocks in AutoCAD, but they're 3D blocks and they've got BIM information embedded behind them. Just show you one other benefit as well. If we want to start looking at room spaces, we can easily come in and define those room spaces. And again, these are all dynamic, so if I choose to move this wall, you can see that all the values update. You can see that everything else moves around and updates automatically as well. If I came down here, I'd have to reconnect the end of the wall to somewhere else, obviously. Okay, and that's the real beauty of what Revit's doing for us. So, drawing sheets as well. So if we, I don't know, we did a section view before, didn't we? If we take that section view, there is our section view. Note it's all updated. It's now got the windows in, whereas it didn't have those before. And we've cropped the roof off. We could reposition that if needs be. We could change that, move it up, so that it includes more of the roof quite easily. If we just think about drawings and say, let's just create a new sheet quickly. there's a standard drawing sheet. To produce a view, it really is a simple case of dropping that in. If we want to change the scale, use the properties dialog box. We can make it a larger scale quite easily. Go the right way to help, wouldn't it? There we go. And obviously annotate and dimension up as you would normally do. So that's a very brief introduction to Revit. I've got a few more things to show, but before I move on, I just want to show you an example of a bigger project that's got far more information in there. So this is a project that's come from industry. So if we come in here and open this project up. So this is a layout of a school, and you can see now that our project browser is far more enhanced. There's an awful lot more information in there. So we've got first floor, we've got ground floor information. All the plan views are similar. So if we look at ceiling plans, we can look at the ceiling plans that are in there, how they're defined. Elevations, so we can look at the different elevations. We can set the scales on each elevation as well, and you can see we've got some trees in there as well, just showing some of the bits and bobs. I'll come back to that in a minute. We look for a standard north view. There's what we've got. We've got some stylization put on there as well. Section views. So this section view is taken as a standard view from Revit, and then our hatching and construction detail has been added in a couple of different ways. So in our cavity here, we've got that added in as hatch, as you would know it in AutoCAD, a similar thing in Revit. But then if we want construction detail like here, then we can actually, well, we pull that from AutoCAD if you like, or typically. So you've probably got this sort of detail already drafted up in AutoCAD. We can just import that as a block in Revit and drop it down to show the right construction detail. Revit doesn't automatically do that for you. It's something you've got to go in and create in your views. Okay. Well, we just come through to, let's have a look. So some of the drawing sheets we've got, not the best one. There you go. So just on a drawing sheet, one of the standard views. If we just cycle through a little bit, I thought we got some more actually. Maybe not. Yeah, so different view with some effects put on there, so on and so forth. So all this data is coming from that 3D model that we created to start with. We're just dropping views down, and that's really where the benefit is. You imagine you need to change the design of this. All of these sheets and all of these views will automatically update for you. Okay. So if I just close this down for a moment, I'll get back to the start. Just close a few windows down. Yeah. So if I get back to my model and I come into my orthographic view, because one of the other things that's very prevalent when we've got a 3D model is to be able to do some visualization with it. So I'm just going to add a bit more detail. So I'm going to add some Japanese maples into this just because we can, really. A bit close to the building as well, but yeah, hopefully you'll get the effect in a minute. Something like so. So I'm adding more components. And the idea here is I want to do a visualization of it. I want to show what the building's going to look like. So I'm going to come in and produce a camera view. My camera view is going to be sort of going through there, I think. So there's my camera view. Not the best in the world, but let's just go back to let's just move the tree around a bit. So I just want to get a bit of detail in there, really, just so you've got an idea of how easy it is to produce this sort of stuff. So there's my my rendered view, my camera view. And I can render that. I can obviously put the view as it is there on a sheet. I can sort of change the view as well and choose how it's going to be shaded. But I can also render this. So if I go for a medium quality render, and I'll let this render away, so I'm not pausing the video, I'll let it do it real time to give you an idea of speed. straight out of the box you can get some really good results with Revit. In fact, because I've done a fair bit of visualization in other products, and this was one area that I was really impressed with on how easy it was to get something straight out of the box. This would be by no means perfect, but it'll give you some idea of how easy it is to produce something. So this is probably going to take, what, around a minute, something like that maybe, to complete. Well, less than a minute actually. But you'll see straight away. The reason why I put the trees in, I didn't quite get it right, but I wanted to just highlight a few things. Probably should have had some more windows and a door on there maybe. Well, straight away you can get a feeling for what we're looking at. The trees in there with some foliage on, but if you notice right at the bottom right here, the tree that's closest to the camera is out of focus. We've got our shadow detail going on, so the sun's quite high. That's based on the date and time that we've specified in the render. We can choose how to set that up. We can pick a location on the globe, and specify a date and time and a year, and it will give us the realistic sun as it was at that point in time, with realistic shadows and so on and so forth. Also a sky background as well. Okay. So rendering is quite an important thing. Walkthroughs and animation as well. Once you've got that 3D model, you can go and choose any of those things to do. It's not free out of the box, but it's part of the solution, and it's very, very easy to do. So if I just quickly come back to some of the rendered views that's with the school, not section views, you can see there that's a draft render. So that took 2 minutes to actually create. If I go up to 4 minutes, you'll see that's pretty good quality. Most companies I speak to, that's the sort of level that they need to go to, nothing more. We can go up to 12 minutes and it becomes a lot smoother. We can also render out into the cloud. So this was done, this is a 16-minute render, but what happens there is the data set gets not translated, but it gets sent out to the cloud, to an Autodesk service. Autodesk servers then render the image and they send you the image back, so you're not processing it. The benefit there is that you can get on with doing your design work or whatever it is you need to do while it's being rendered in the background somewhere. Okay. We can also do the stylized views as you saw in the drawing frame before. They've been done via the cloud. Okay. So again, it's being done via via different means, if you like. So you've got different options to generate these rendered views. Okay. And then one last thing to touch on really, if I just come back to my model. Let's get into our 3D view a little bit. So there's our 3D view. You know, we're talking about BIM really, and hopefully you've got a flavour of the BIM families. I'm going to expand on that more from a mechanical point of view in a moment. But within Revit, all we're interested in doing really is just bringing those families in and placing them into our model. The families should have the right information embedded. We can embed that into Revit, through Revit rather, if they haven't, but generally you're pulling in manufacturer's detail. As far as export of information goes, we're able to export all that information out in a COBie format. So the COBie format defines how it should be set up. We can specify what we want to export, what worksheets, and then just tell it to export that information out to a file. If we look at a file, this is a typical COBie datasheet. This is just a sample one. This is the sort of data that you'll see in that COBie spreadsheet, and this can come directly from Revit. Okay, so contact information about the different things, the companies, telephone numbers, all of that information is embedded within the model. If we look at components, so these are the different components. So plumbing here, been created by, created on, the date and time, what the actual name of it is, and then going through we can see additional detail about it. Now, not everything's filled out. That isn't what COBie's about. It's that you don't have to fill out all of these fields. So you can see these fields are not applicable, but where they are applicable, you're trying to put as much information into the model as possible, so that later on down the line, maybe years later on down the line, somebody can easily pick up that digital model and just dive straight into it and look at what data's there. And that's what BIM's all about. So, hopefully, oh, just one other thing as well, I'm not going to do it, but just quickly talk about it. Obviously, most people that are coming to Revit, new, if you like, or you know, being introduced to Revit, would be coming from an AutoCAD background. So within our drawing sheet, click the wrong button. Within our drawing sheet and such like, we can export these out. So we have options where we can save them out to an AutoCAD format, as you'd expect, really. Okay. So we can, you know, if your delivery format's AutoCAD, then you can do that as a standard DWG file. You can link that back as well. So that, in a brief nutshell, is a very brief overview of what Revit does with a BIM slant on things. It's all about families, it's all about libraries and bringing that library information in. That library information has all the relevant BIM information embedded into it. Because of that, as you build your model, all of that BIM information is embedded into your model. Okay, so the last thing we're going to look at is manufacturing workflow, where we're taking inventor data into Revit. I'm going to go through this quickly because the inventor side of it's not really the focus for today, but basically we've got an inventor assembly. This is only a very simple assembly, but the complexity doesn't matter. We can use the same technique with whatever it is. It's a part which is the vessel shape with some branches on it, and then two flanges that are from content center. What we're going to do first of all is simplify the design. So we're simply going to say create this as a simplified component, as a single part. So I'm not bothered about the assembly data at all. So I come in and tell it I want to recognize information so that I can bring that across to Revit. And I'm not bothered about the internals of this, so I'm simply going to cap off. And I could choose an automatic option here, but I want to keep the bolt holes. If I choose that, it's now filled that in completely. So from a geometry point of view, it's far simpler. I can then ask it to recognize different features for Revit. So Revit could actually recognize these things as extrusions and part of the modeling environment, so we can modify it in Revit if we wanted to. We don't have to do that, but I've just chosen to in this case. And then once we've finished that, I could export that to Revit now, and I can pick it up in Revit and use it. But as it stands at the moment, that we need some more information. We need some connection points on here because these are flanges, but we also need the Kobe information put in there. And we can do that in Revit, or something that we've done at Man and Machine is we've written a couple of little routines. In fact, we're now creating a BIM toolbox for Inventor, which allows us to populate property information according to BIM. So a standard dialog box to enter information. These are all the fields that are required for the BIM standard or the Kobe standard. Okay. So if I just drop some details in here, I'm not going to fill them all out, obviously. So now, and then 1, 2, 3, and material. Let's say copper for today. Okay. So that's me done. If I now go to our BIM Exchange tool within Inventor, I can say, well, I can just send this straight out, or we can say I want to specify some connectors. So that there is a connector. It's circular, it's picked the right size up already, but I could override that obviously. And it's domestic hot water. I've got more property information in here that I can fill out now, and this all goes towards your BIM information. I'm not going to populate any of that for what we're doing. And if I do the same on here, just flip the direction around this time, say that's cold water. So I've preset the connectors on here ready for Revit, but I've done it in Inventor because the design guy knows what he's designing this, so he knows what these values are. It makes sense for him to put that information in rather than somebody having to do it in Revit. Once I've got that done, I can then save this. So if we, let's just, in fact, I can leave it there, call it equip, and then if I just orientate it correctly, it's going to be saved as a Revit family file, an RFA file. So all the information's there. At the moment this is the property detail, but if I choose to include all property information, you can see now all that BIM information is automatically being exported, including the ones that I modified. Okay. And if I save this away, and if I drop this into our demo folder, let's call it demo heater for today. What's going to happen is it's now translating the Inventor data into Revit data and building a family in the background. So it's processing this through, as you can see the progress bar going across. Once that's done, it's a fully fledged Revit file, and we'll go and have a look at that briefly in Revit. Almost there. There we go. So you have a report just to tell you if there's any problems or it's encountered any issues. In this case not, it's usually the case. So if we go back to Revit briefly and basically say, right, I want to insert a component now. Well, that's one I've done before. If I choose to load that in, so if I come in here and say BIM demo, I want demo heater. So it's going to load that equipment in. As you can see, I've got that in there. I've got one I've done before as well. So I can now drop that in anywhere inside of my model, just as I did before, with windows and doors. So that's me creating a BIM model inside of Inventor and then sending it directly to Revit, or saving it and then utilising it in Revit just by loading it in. If you look there as we look on the actual BIM model, you can see we've got specifications for the connections. And if I come in here, we've got information here. But if I go and edit the type, all these D values here are dimensional values that's come from Inventor because I chose the way I chose to do it. I could actually modify these parameters and change the size and shape of that model in Revit if I wanted to. So we're probably not too interested in that, so the dimensional information is off. But if we then scroll down the list, all our COBie information or BIM information is actually here. So heater, MM123 and copper. That's what I authored in Inventor and sent directly to Revit. So that is our BIM model done from Inventor and utilised in Revit. That's a huge benefit for manufacturers who have to produce BIM models, so that we can do that directly in Inventor and then generate those files and publish them out to the web or wherever it is that they need to be utilised. Okay, so all it remains for me to do is thank you for your time today, really, and open the chat or the webinar for questions and answers. Thank you.